Okay, so if you might have seen it, but probably not. Okay, so first of all, what is it for? What does it do? This finds roots. That's the purpose of it. Okay, it finds roots for us. I guess better it would say it finds possible roots. So it's a way to find the roots. Okay, it's a way from polynomials. So I'm going to explain it first to show you how it works. So I'm going to give you kind of an example. Let's write x cubed plus x squared minus 5x plus 3. Okay, I want to show you. Okay, so there is information that we know. There's a lot of stuff we know. Like we know it's odd power. So remember when it's not in parentheses, that's called standard form. The highest degree, the highest power is your degree. So that's your degree 3. So it's going to look like this because it's positive. So I do know what it's going to look like. Okay, I also know the end behavior. The right arm goes to infinity. The left arm goes to negative infinity. I didn't write it the proper way, but just getting to it. Okay. Bless you. I also know my y-intercept. It's 3. Okay, I want you to be able to do that, like be able to find it like that. Because if you plug 0, 0, 0, those cancel to 0. Okay. So a lot of information, but the really important part here is that you don't know your roots. Okay. So what I mean by that is if I were to graph this, I don't know where it's touching right here. I don't know. Okay, and that's a big deal. Okay, that's a really big deal. And notice, if I try to factor this by grouping, okay, let me try it. I just want to show you one time that not all problems factor by grouping. Like we have to go look for problems that work for you. So if I do this, I can take our x squared out. And what can I take out of that second group? Well, for sure, always at least -1, right? At least. But even if you do that, if you notice, they're not the same. And there's nothing you can do to make them be the same. Okay, so on this case, I can't factor by grouping. Now you should try, like if we're not specifying, hey, do this problem this way, you should try to factor by grouping first because that's the easy one. Okay. So if we can do it this way, this leads us to what you're going to learn today. So it's x cubed. I'm just writing it over. Okay, guys. So we call this for the rational root theorem. Okay, we call this number right here p, and we call this number. So the first number is p. I mean the last number. The first p is first number is q. Okay, in this case is 1. That's the easiest one. When now it's 1, that's the easiest problem. Okay, so we're going to do the easiest ones first. So we call that one P, this one Q. Okay. Now, the first part to this, okay, is we need to figure out the factors of those numbers. Okay. Factors just mean what number times what number multiplies to that number. So what's the only numbers that multiply to 1? 1. So 1. Okay, over here, what's the only numbers that multiply to 3? 1 and 3. Okay. Okay, everybody's good with that, right? But here's where we start to get a little confused. We also put, is it true that -1 times -1 equals +1? Negative times the negative is a positive. So we must include the positive version of 1 and the negative version of 1, because negative times the negative is a positive. Same thing with 3, okay? If you do -1 times -3, that's also positive 3. So just a shortcut, you're always going to have plus minus, plus minus, plus minus. Okay? Okay, does that first part make sense? That's the first step.
So if it was a -3, would you do a negative and a positive?
It's the same. You can do plus minus, yeah. I'll tell you, the plus minus takes care of both. Good question. Any other question, guys? Okay, so why do we need P and Q? Okay, so, and I'm going to leave this here for you because I forget myself. Okay, so I'll have that up for there. But what we're looking for, what we want is P over Q. Okay. This P over Q, okay, what it does for us, it finds the list, it makes a list for us of possible. So it doesn't find the roots for us, it finds potential possible roots. Or remember, roots just means x-intercepts, which is what we're missing on this problem. Okay, so it's going to find those. Now, because otherwise, so remember yesterday, let's connect it to yesterday. Remember how you were dividing yesterday this, you're doing synthetic division? And if you got a 0, it was the root. What are we going to divide this by? They didn't tell us, right? So we don't want to just throw numbers because there's an infinite amount of numbers. So this shortens the list to a few numbers instead of an infinite amount of numbers, okay? And here's what it is. So it's P. P is, now I'm going to be shorthand here and I'm going to put plus minus in the front. That way it applies to everything so I don't have to write it over and over and over. Okay? So P is 1 and 3 and Q is 1. I'm going to write it once to show you what this is like a condensed version, but it's very efficient. But what this really means, it's 1 over 1. It also means, see how we have a negative too? So it means negative 1 over negative 1, negative 1 over 1, all those different combinations. 1 over negative 1, which is the same thing, 3 over 1. But at the end of the day, here's the even shorter version of that. It just really means, what is 1 over 1? 1, so plus minus. Well, actually, let me do it shorthand and then long. 1, and then what's 3 over 1? 3. So all that is just this. Okay, and that's why these are the easy ones because they're just dividing by 1. I don't know if we'll get to them today, but if this was a 2, then it'd be 3 over 2 and 1 over 2. And so. Now, what does this really mean? You have a 1, a negative 1, a 3, a negative 3. That's the condensed version of that. That way we don't have to write them all out. Okay, a positive 1 and a negative 1, a positive 1. Okay, right here, guys, this is the important part. See this list of possible? That's this list. Okay, so now we don't have to just plug numbers at random and see if we get lucky. It has to be one of those numbers. Okay, so it shortens the list to not an infinite amount of numbers, a certain amount of numbers. So the question is, now to make this easy for you, I'm gonna call these the maybe roots. Okay. They might be, some of them, not all of them, some of them. So that's why you did synthetic division yesterday, okay? Let's write it again. X cubed, well, you don't have to write it again. I'm gonna write it again because I can't see it anymore. So I'm gonna synthetic divide. If you were absent yesterday, there's a short video from teaches you this very thoroughly like we did yesterday, so, or if you didn't get it, okay? So I'm going to test these numbers out, okay, and see which one's the root. Start with the easiest one of those numbers, 1. Okay, make the math easy. So let's synthetically divide. First number drops, multiply, 1 times 1 is 1, 1 plus 1 is 2. Multiply, add, multiply, add. 1 times 2 is 2, negative 5 plus 2, negative 3. Be very careful with your signs. 1 times negative 3 is negative 3. 3 plus negative 3. Okay, that means this right here. And notice one thing, I didn't flip. I'm not flipping those. Those are the roots. They're not factors. That's when you flip them. Okay. So this right here is a root. It's not a maybe root. It is a root. Okay. No, that's a nice thing. But before I do that, x-intercept, so I found one of them. X equals 1. So I don't know if you heard Aiden, but he said, do we have to do all of them? You could. Okay, you could test all of them. But we already found this one set. But here's what's the nice part about this. Let's write our answer to this, right? So this is, that one's x cubed, so this one is x squared, right? 1x squared plus 2x minus 3. You have options, though. No? I want you to know your options. You could, if you like synthetic division, it's easy for you. You could keep synthetic dividing those and see if they turn out to be true or false. What I would do is I would factor that. Okay, so, and that's going to give us our other two roots. So you can either keep on dividing or factor that problem to get your other two roots. Okay, so 3 and 1, right? Which one's positive, which one's negative? 3 is positive, 1 is negative. But those are factors, not roots, right? Roots are opposites. So that's what rational root theorem is about. Okay, it helps us not find the roots, but it helps us find a list of possible roots. And then we can find the roots from that list. Now notice something here. Well, any question right now? And that's the very first example, so it's a little rough, but that's the gist. Okay. Notice we already had 1, and then we got 1 again. What does that mean? How come we got 1 twice?
Oh, would it be a negative 1? Oh,
No, it's a 1. Remember on the test, we told you in words, double root is this. So that's a bouncing 1. I'll show you what it looks like. It's hitting the 1 twice, I guess. So let me show you. Once you see it visually, you'll know what I'm talking about. So here we go. Okay, we have a root at -3 and at 1. And can you guys tell me the y-intercept so I don't have to scroll up, please? 0, 3. Okay, so right here, we know it should look like this, right? So try to think, how can you make this look like that with only 2 points? So here it is, okay? Let me do a different color. Double root, this is what double root means. Bounces on the 1. Okay. Does that make sense? Okay, there it is. Okay. So not a rough sketch, super accurate sketch this time. Questions right now? Yes?
So would you have to do both methods to find the double root, or can you just use one?
No, you can just use 1. They'll show up. For example, if somebody here would have tried, well, they wanted to start with the 3s first, they would have found that one first. And then they would have got a different problem that they could have factored in. They would have got 1 and 1 twice. Yeah. Okay, good questions. Other questions, guys? Yeah, I mean, if you kind of got the gist of it, that's the main idea. Okay, let's try example 2. We're gonna keep trying it until we get really good. Let me break this up though, that way when you watch this, you don't have to watch all